Yeah, so I'm Peter. I work as a data analyst at 15 Gifts. As far as I know, we have nothing to do with Mark Rittman. And my talk has nothing to do with business intelligence and very little to do with data science. Maybe it'll touch on it a little bit. But I'm here to talk about organizing your analyses. And now that might not sound like the most inspiring talk ever, but I think it's really important. And I'll explain why. So this is essentially the talk that I wish I'd had when I started at 15 Gifts just under 2 years ago now. Previously I'd studied maths and stats at uni, so I'd done a bit of training there in terms of like applying R and things like that. And then I had a role at another company where I was sort of, it's probably quite a common story actually. I wasn't strictly a data analyst, but because I could do it, I was sort of drawn into a lot of data analysis projects and ended up becoming almost a de facto data analyst because I could. I was pretty good at Excel and R and could deal with that sort of stuff. So why do you need to organize your analyses? Well, it's not for you right now. It's for you in 2 months' time. When I first started at 15 Gifts, I wasn't ready for someone to turn around a couple of months down the line and just say like, oh, could you redo that thing that you did a couple of months ago? Or what about this? We never looked into this. You go back to your code and you're like, what was I thinking? Why did I do that? This makes no sense. Did I even write this? So being a little bit more organized is really fundamental for that kind of repeatability, coping with those questions that are almost inevitable. You won't get them for every analysis, but you get them often enough that it's worth putting in that little extra bit of effort to make sure your work is organized. And if you're sitting there thinking, oh, I've already on top of this, well, like I said, my story of coming from a sort of fairly independent worker is very common within this industry. And those people are quite often used to just getting stuff done. They only ever work on their own code. They don't necessarily work in a team, or they've never really shared their work before. So if you're more of a senior analyst and you've done this day in, day out, it's really important that you have a think about, how do I organize my work? And people joining my team, have they actually had any training? Do they know any of this stuff that I just take for granted? So that's the why. And hopefully I've convinced you that it's important and might be a little bit useful. So now we come to the how. Now, the quick disclaimer, this is how I organize my work. Hopefully it's the general rules and the general ideas are sort of like fairly standard, but if you disagree with anything, that's completely fine. Disagree. Find out what works best for you and your team, but the key thing then is, I guess, sort of loosely sticking to it. I mean, obviously, more guidelines, really. You can definitely break whatever rules you put in place when it's useful, but generally speaking, the way I think about things is, will I be able to rerun this analysis in a couple of months and on a different computer? Because that quite often happens, whether that's someone else actually using your work, maybe you're on leave and someone else has had to like desperately cobble together this report that you're the one that always sends. Or maybe you've just been asked a question and you've got to go back into the dregs of history after doing loads and loads of different stuff in between and you're trying to work out what you were thinking. So the two key things here is that each of your tasks, we ticket our work, so everything's quite like nicely broken down, should be fairly self-contained. Everything to do with that one analysis should be in one place in its own little thing. And that's really fundamental when you start moving across computers or working together, because that means it should all be there. You can't rely on something that's only on your machine or in a different folder that no one else will have. And it's got to be understandable, because although it might make perfect sense why you did that now, you won't remember it. I always find that with coming to these talks, I never write anything down, and I'm always like, oh, that sounds great. I'm going to remember that, and then I forget it immediately, either in the pub or the morning after. So making sure that your work is understandable when you look back on it is really critical as well. So here are how I sort of focus and get my work to be reasonably self-contained. The key thing, no matter what, is your analysis needs to be in a single folder, or at least that's how I organize my work. And that means everything. No more sort of like mega 1,000 line long SQL query that you just keep adding to your big scratch pad, or worse, you delete whatever queries you were doing before and just overwrite them with like a new question that you've got to answer. Make sure that you save all your queries, all your code, any data sets you've used, and your output if possible. Or if you're hosting your output somewhere else, just write a little README and put a link to it so that everything you need about that analysis is in that folder. And even if you start doing that, you're already in a much better place to make sure your work is like in a good place to be shared, and also that you'll be able to kind of like at least find everything. That's the bare minimum, but that alone is sometimes hard enough. Next, this one's a bit more code focused, I guess. In our kind of tying in with that idea of having a dedicated folder, In R or Python, if you use full stop when you're referencing any files, that refers to your current working environment. And our current working environment, you can set that in a couple of different ways, but essentially what you'd end up doing is have that folder as your current working environment, and then everything is kind of like relative to where you are. So if you have a file, if you've got a data file that's within your current folder, instead of having this kind of like hard-coded, this is how I organize my work path to that file, I can just use the full stop and then reference that data file within there. And that is really critical because this breaks as soon as you rearrange your folders, send it to someone else, or just you could just rename a folder and that breaks immediately. Whereas this one, because everything's within that folder and all of this is relative to that folder, that will keep working, which is really critical. There's loads of stuff about organizing your work on the internet, and I read a very entertaining article. It was a rant essentially from a university professor who had to mark like 30 analyses for like a data course or something, and every single one of his students had used this. So every time he was marking anything, he had to go through and manually edit every single reference, and he threatened to burn their computers at the end of it, which was quite fun to read. But so that's, relative path to files, really make sure that everything's kind of contained within that folder. And run things from scratch. Any kind of code you write or analysis you do, you should at least try and test what you're doing to make sure that it's doing what you expect and makes sense. And this is just the check that everything is actually self-contained. It's quite easy if you're in R or Python to refer to a variable that you might have set if you switch context quite quickly, or a library that you loaded for a different analysis but haven't quite restarted yet. And you forget what you've actually included in this particular analysis. So periodically just closing everything down, not saving your workspace, restarting the kernel or notebook, whatever, run everything from scratch and check it still works. And that will save you, again, that'll save you some headaches later. So that's just how you test that your work is actually self-contained. Next, the second point was making sure that your work's understandable. So the key thing for me with this is finding a file structure that works and then sticking with it. So this is just what I use. This won't necessarily be right for your analyses, and there's loads, again, online about suggested ideas for data science projects, for biology research, for data journalism. There's a whole blog about learning R for data journalism, which was quite interesting, and they have a folder structure that they suggest there. But the key thing here is that you once you've got a folder structure that works reasonably well for you, try to stick to it. Generally speaking, I mean, you'll break the rules sometimes, but having a structure that's pretty much always the same means that no matter when you go back to that work, it'll still make sense. You'll know where to find things. The bit that's really crucial for me in this one is that master.r script. And what I know that does for me is that ties everything together. So this might not have all the actual analysis in it, but it'll at least tell me how all of the things in the subfolders link together. So that means that I know that I can find everything that I need for the analysis within that folder, but also I have one document that I can go to, and that'll tell me roughly what's supposed to happen and why. So yeah, that's the folder structure. But then once we've got that main script, if you're going down that route, that's sort of one thing that ties everything together, get as much detail as you can out of that script and into something else. In R or Python, that'll probably mean learning how to use functions, which I didn't know when I started at 15 GIFs, but have been a revelation. And if you move those functions somewhere else and try and make your code human readable, it makes it much easier to scan when you come back to it. So if you've got a complicated data preparation step that's got lots of wrangling, weird exceptions, replacing, regexing out different like strings, that sort of stuff, move that to a function. You've still got that code. You can still look into it and change it and edit it if it breaks and you actually need to. But if you're just coming back to that analysis and sort of like skimming through it, you don't need to know all of that detail. You just need to know that you've prepared the data and you can look at the output and reasonably remember what you did. So move that detail somewhere else. That'll also help other people that are looking at your work because it becomes human readable. They don't need to understand exactly what you were doing. They just need to get the gist of it. And then finally, if you're coding, add comments. It costs you a couple of seconds to add in a comment about why you did something or what you did, and it saves you such a headache later on, particularly with regex, which is if you guys don't use it, that's a way of kind of looking up different things within a string. They can get very complicated and very long, but explaining what that's supposed to achieve goes a long way to speeding up someone else reviewing your work or you even looking back on your work. So yeah, comment your code if you're using code. And I think some of these principles you could also apply to other types of analysis, maybe in Excel, adding a little explanation to a column of like why you're doing something that way, rather than just having it there and letting people try to work it out. And that's pretty much it. So yeah, think about take a few moments next time you're doing an analysis and think about, is this organized? Will I be able to, if I had to, extend it or answer a question a couple of months down the line? Would it make sense to me then? And achieve that by making sure it's self-contained and making sure that it's actually understandable if you had fresh eyes. Yeah, that's all I've got. So I don't know if there's any questions about that.
Thank you very much. I'm tempted. Well, I'm going to allow a couple of questions. Here's Pranath.
Hi, really great to hear about your process. Very clear and very practical suggestions, I think, for everyone. So I just wanted to, I suppose highlight a few things that may be of interest to you as well, that may complement actually your approach. So just a bit about my background. I'm sort of moving from a sort of web and software development background into data science and machine learning. And there are things I find from my current background that I think I would look forward to using in the other. So one is version control. So there's something called Git.
Yep.
If you've heard it, basically. So for me, like everything I sort of utilize with Git in terms of my sort of web development background, it just seems very useful in terms of, so within a project, historical sort of points and being able to very quickly sort of roll back to specific versions within a project. So maybe that's something, I think the setup is not too bad. So, I mean, maybe that's something, you could look into, or maybe.
Yeah, well, actually at 15 Gifts within the analytics team mainly, we've a couple of months now, for the past couple of months, we've been hosting all of our code within GitHub and actually version controlling things and adding comments. It's horrendously messy in terms of like a dev approach. Everything's in one branch and just we all push to that. But at least it means that there's some record of what happens, and it's quite easy for everyone to kind of review each other's work, make changes, store a little bit of that history. But again, some of the research I did earlier on for this about kind of particularly more complex projects, when you're going into more complex data science projects or even big research projects where there's a lot going on, something like Git can be very powerful. It's a bit, when I first learned it, it was very confusing. But then the guy that taught me made me do everything on the command line, which probably didn't help. But yeah, no, it is incredibly useful. And yeah, I'd definitely recommend at least trying it to other people.
So just as another thing in terms of, like you had with your folder structure.
Yep.
Just another source of maybe ideas for how you do that are what called software design patterns. So for example, there's one called Model View Controller, which is a very common one. It's just another way of sort of organizing.
Oh, what does that mean?
It might be better to Google it, but yeah, if you look at software design patterns, and in particular Model View Controller, it's a very, very simple way of organizing your code that you could use for that. For example.
Oh, cool. I'll look into it. Thank you.